Okay, so so we're looking at, we have a parametric curve, right? And we want to take that parametric curve, translate by this specific vector a comma b, and we want to find a parameterization of the resulting curve. So let me draw a picture, what that looks like. Here's our xy axis system, and our first curve I'll do in blue, let's say. Oh, that's bad. That's making it too hard. There we go. So here's our first curve. What was it called? We didn't give it a name. Fine. But anyway, this is P of t. Is that what I called it? Yeah, P vector. Okay, now we want to take that curve and we want to translate the whole curve by way of some vector AB. And the result then will be this new curve that I guess I will do in green, let's say, and I hope I can make a decent, something like that. Right? So I want to find a formula for this parameterization. So, position as a function of time. Let's see, what did I call that? I called it t. Okay, so there's a picture of our context. Is everybody happy? That makes sense? Okay. Okay, here's the good news. P of t gives location as a function of time, but I can think of that as being represented, let's see if I can shoot straight. There we go. Represented by a vector. And green, right, T of t, again, that's position as a function of time, but I can think of that as being given by a vector. And furthermore, I know that these are translations of each other by way of that same vector a comma b. Right? And now let's just look at this little triangle we have here. That triangle is a vector addition triangle, right? And so specifically, t is equal to p plus AB. Whoops, I forgot to. There we go. Plus AB. All right, like this. So there you go. So that's how you do it. And so now we were given specifically that the parameterization there has coordinates P1 and P2. So let me write that down. This is P1, comma P2. And so all together then, and I'll just switch to black. So T of t is P1 of t plus A, P2 of t plus B. Everybody happy with that?
I see. Okay.
Yeah,
that makes a lot more sense.
Yeah, cool.
I think I was just reading the question.
Oh, yeah, sure. No worries, yeah. So for those listening on the recording, let me make the observation that this connects back to an exercise back in section 2.2 where we talked about symmetric equations of lines, the corresponding parameterizations of the lines, and understanding how translations applied to the symmetric equations allowed us to draw a conclusion about how translations applied to the parameterizations. And we came up with an analogous result for that one. Okay, cool.